Let's start with the HashSet class in Java. HashSet implements the set interface and is part of the Java collections framework. Its main purpose is to store a collection of unique elements, meaning duplicates are not allowed. Internally, HashSet uses a hash function to map each element to an index in an array, which allows for fast access, addition, and removal of elements. As long as the hash function distributes elements well, basic operations like add, remove, contains, and size are performed in constant time. This makes HashSet a great choice when you need to ensure uniqueness and efficiency in your collection. Moving on, LinkedHashSet is an ordered version of HashSet. It maintains a doubly linked list across all elements, which preserves the order in which elements are inserted. This is especially useful when you need to iterate over the set in the same order as insertion. For example, if you add numbers 1, 2, 5, and 3 to a linked hash set, they will be returned in that exact order during iteration. Linked hash set combines the uniqueness of hash set with predictable iteration order, making it ideal for scenarios where both are important. Map interface is a key part of Java collections. It allows you to store values in key-value pairs, ensuring that each key is unique. Maps are found in the Java util package and provide methods like containSkey and containsValue to check for specific keys or values. There are several types of maps, including sorted map, TreeMap, HashMap, and LinkedHashMap. Each offers different features, such as sorting or maintaining insertion order, giving you flexibility depending on your needs. TreeMap is a specific type of map that stores data as key-value pairs and is implemented using a red-black tree. It ensures that all elements are unique and maintains them in ascending order. TreeMap does not allow null keys but can have multiple null values. It is not synchronized, meaning it is not thread-safe by default. TreeMap is useful when you need sorted data and efficient access, as it automatically keeps entries ordered by their keys. NumSet is a specialized implementation of the set interface designed for use with enumeration types. It is faster than HashSet and does not allow null objects, throwing a null pointer exception if you try to add one. All elements in an enumSet must come from a single enumeration type, making it ideal for situations where you need to work with a fixed set of constants. EnumSet uses a fail-safe iterator, ensuring safe iteration even if the set changes. BlockingQueue is a queue implementation that supports operations which wait for the queue to become non-empty when retrieving or removing elements, and wait for space to become available when adding elements. This is particularly useful in concurrent programming, where threads may need to wait for resources to become available. BlockingQueue is defined as an interface, and its generic parameter specifies the type of element stored in the collection. ConcurrentHashMap is a thread-safe implementation of the map interface, built using a hash table. It allows concurrent access to its entries, making it ideal for multi-threaded applications. The default concurrency level is 16, and it does not allow null keys or values. This ensures that operations are safe and efficient even when multiple threads are accessing the map simultaneously. Its syntax and structure make it easy to use for concurrent data storage. You can use any class as a map key in Java, provided it follows certain rules. The class must override both the equals and hashcode methods to ensure proper functioning. This is important because map relies on these methods to compare keys and store them efficiently. ConcurrentHashMap is thread-safe, and its default concurrency level is 16. However, you cannot insert null objects as keys or values in ConcurrentHashMap. The iterator interface provides methods to iterate over any collection in Java. It replaces the older enumeration interface and allows you to get an iterator instance from a collection using the iterator method. One of its key features is the ability to remove elements from the underlying collection during iteration, making it flexible and powerful for traversing and modifying collections. Enumeration is a user-defined data type in Java, mainly used to assign names to integral constants. This makes programs easier to read and maintain. The main objective of enum is to define user-defined data types, allowing you to work with named constants instead of raw numbers. For example, you can define an enum called color with values red, green, and blue, making your code more expressive and less error-prone. In Java, collection and collections are different. Collection is an interface that provides standard functionality for data structures, while collections is a class that offers static methods for sorting, synchronizing, and performing various operations on collections. Understanding this distinction helps you use the right tools for managing and manipulating your data structures efficiently. Arrays and array lists in Java have key differences. Arrays can be single or multidimensional and have a fixed size, while array lists are dynamic and can grow or shrink as needed. Arrays store primitive data types directly, but array lists only store objects, using autoboxing for primitives. Array lists offer advanced methods for manipulation and are type-safe, whereas arrays require manual resizing and basic methods. Arrays in Java have a fixed size and store elements in contiguous memory locations. They can hold both objects and primitive data types. Collections, on the other hand, are dynamic and can grow or shrink automatically. Collections only store objects and offer advanced methods for manipulation and iteration. Arrays have been available since the beginning of Java, while collections were introduced in Java 1.2. ArrayList is implemented as an expandable array, storing elements in contiguous memory locations. It is faster for random access and more memory efficient. LinkedList, however, is implemented as a doubly linked list, storing elements in non-contiguous memory locations. LinkedList is faster for insertion and deletion operations but less memory efficient. ArrayList is better for search operations, while LinkedList excels in modifying the collection. ArrayList and Vector are both resizable arrays, but ArrayList is not synchronized, making it faster for non-concurrent operations. Vector is synchronized and slower due to added overhead. ArrayList is recommended for single-threaded environments, while Vector is better for multi-threaded scenarios. The default initial capacity for both is 10, but Vector increases its size by doubling. ArrayList offers higher performance overall. Iterator can traverse elements in a collection only in the forward direction and is used for map, list, and set. List iterator, however, can traverse elements both forward and backward, but only for lists. List iterator provides methods to obtain indexes and modify or replace elements, while iterator cannot. List iterator also allows adding elements at any time, making it more versatile for list manipulation. HashMap is not synchronized and allows one key to be a null value. It uses an iterator for traversal and is faster than hashtable. Hashtable, on the other hand, is synchronized, does not allow null values, and can be traversed using both iterator and enumeration. Hashtable is slower due to synchronization overhead, making HashMap preferable for most scenarios unless thread safety is required. Iterator can traverse both legacy and non-legacy elements and is fail-fast, meaning it throws an exception if the collection is modified during iteration. Enumeration can only traverse legacy elements and is not fail-fast. Iterator is slower but allows removal of elements, while enumeration is faster and only allows traversal. Understanding these differences helps you choose the right tool for collection traversal. Comparable is an interface in Java, lang package, providing the comparator method for sorting elements with a single sorting sequence. Comparator is in Java, util package, and offers the compare method for multiple sorting sequences. Comparable affects the original class, while comparator does not. Use comparable for fixed sorting and comparator for custom sorting based on different attributes. Set and map are both implemented using Java, util package. Set extends the collection interface and does not allow duplicate values, while map does not extend the collection interface and allows duplicate values. Set can sort only one null value, whereas map can sort multiple null values. Understanding these differences helps you select the right structure for your data. Fail-fast iterators throw a concurrent modification exception if the underlying collection is modified during iteration. This is the default behavior in Java collections framework, such as with HashMap. Fail-safe iterators, like those in ConcurrentHashMap, do not throw exceptions and instead iterate over a snapshot of the collection. This distinction is crucial for concurrent programming and avoiding runtime errors. Exception handling in Java is a mechanism to deal with errors and unplanned occurrences during program execution. Exceptions can be caused by device failure, loss of network connection, code errors, opening unavailable files, invalid user input, or physical limitations like running out of disk memory. Handling exceptions ensures your program can respond gracefully to unexpected events and continue running. Java exceptions are divided into two main types, built-in and user-defined. Built-in exceptions are provided by Java libraries and include checked and unchecked exceptions, such as array index out of bounds exception, I/O exception, and null pointer exception. User-defined exceptions are created by programmers to handle specific situations not covered by built-in exceptions. This flexibility allows for robust error handling. Errors in Java are unrecoverable and mostly caused by the environment, such as Stack Overflow error or out-of-memory error. Exceptions, on the other hand, can be recovered from using try-catch blocks or by throwing them back to the caller. Errors are always unchecked, while exceptions include both checked and unchecked types. Understanding this distinction helps you handle problems appropriately. All exception and error types in Java are subclasses of the throwable class. This class forms the base of the hierarchy, with exception and error as its two main branches. Exception is used for conditions that user programs should catch, while error is used by the Java runtime system for serious problems. Understanding this hierarchy helps you manage exceptions and errors effectively. Runtime exceptions occur during code execution and are not checked by the JVM at compile time. Examples include null pointer exception, array index out of bounds exception, arithmetic exception, and illegal argument exception. These exceptions do not require declaration in the throws clause or capture in a try-catch block, but handling them is advisable to prevent system crashes and provide meaningful error messages. Null pointer exception is a runtime exception thrown when a program attempts to use an object reference that has a null value. It indicates that no value is assigned to a reference variable and is commonly used in data structures like linked lists and trees. Handling null pointer exception is important to avoid crashes and ensure robust code. Array store exception is thrown when an attempt is made to store the wrong type of object in an array of objects. For example, if you try to store an integer in a double array, Java will throw this exception. This helps maintain type safety and prevents unexpected behavior in your programs. Checked exceptions are checked at compile time and must be handled or declared using the throws keyword. Examples include IO exception and interrupted exception. Unchecked exceptions are not checked at compile time and include error and runtime exception classes. Understanding the difference helps you write safer and more reliable code. Both error and exception in Java share a common parent class, Java, lang, throwable. Errors are illegal operations causing abnormality, while exceptions are unexpected events disrupting normal program flow. Knowing the base class helps you understand the structure and handling of errors and exceptions in Java. In Java, it is not necessary for every try block to be followed by a catch block. You can use a finally block instead, which runs regardless of whether an exception is thrown. This flexibility allows you to ensure certain code always executes, such as resource cleanup, even if an error occurs. Exception propagation is the process where an exception moves from the top to the bottom of the stack. If not caught, it drops down to the previous method, and so on until it is caught or reaches the bottom of the call stack. This mechanism ensures that exceptions are handled at the appropriate level in your program. If you use system exit 0 in a try or catch block, the finally block may or may not execute. If a security exception is thrown, the finally block will run. Otherwise, the JVM will close and the finally block will not execute. This behavior is important to understand when managing program termination and resource cleanup. Object cloning is the process of creating an exact copy of an object. To achieve this, a class must implement the clonable interface and override the clone method from the object class. If the clonable interface is not implemented, overriding the method alone results in a clone not supported exception. Cloning is useful for duplicating objects without manual copying. If exceptions are not handled in your program, they cause abrupt termination, and any code written after the exception occurs is not executed. Proper exception handling is essential to ensure your program continues running and provides meaningful feedback to users. The final keyword in Java is used to make functions non-virtual. By default, all functions are virtual, but using final prevents them from being overridden. You can also use final with variables and classes to prevent modification or inheritance. This ensures certain behaviors and values remain unchanged throughout your program. Java uses three similar-sounding keywords: final, finally, and finalize. Final is used with variables, methods, or classes to prevent overriding. Finally is a block of code used with try-catch for exception handling, ensuring code runs regardless of exceptions. Finalize is a method called before an object is deleted, allowing for cleanup activities. Understanding their purposes helps you write safer and cleaner code. This keyword represents the current instance of the class and calls the default constructor of the same class. It also accesses methods of the same class. The super keyword represents the current instance of the parent class, calls the default constructor of the base class, and accesses methods of the parent class. These keywords help manage inheritance and constructor chaining in Java. Multitasking in Java refers to a program's ability to carry out several tasks at once. This is achieved using threads, which are lightweight operations within a single program. By executing multiple things simultaneously, Java programs can make efficient use of resources and improve performance. Multitasking is essential for modern applications that require responsiveness and concurrency. Multithreaded programs in Java contain threads that run concurrently instead of sequentially. This allows a computer to use its resources more efficiently by combining multiple tasks at once. Multithreading enables more than one user to use the program simultaneously without running multiple copies. It improves performance and allows programs to utilize multiple processors, boosting overall throughput. In Java, you can create threads by extending the thread class and overriding the run method. Each thread executes its code independently, and you can start multiple threads to run concurrently. For example, starting two threads will allow them to print their IDs and values simultaneously, demonstrating Java's multitasking capabilities. Multithreading allows programs to run multiple processes at the same time, improving performance and enabling efficient use of resources. It is especially useful for applications that require responsiveness and simultaneous operations, such as servers and user interfaces. Multithreading also allows programs to utilize multiple processors, increasing throughput and scalability. Java Collections Framework provides several classes and interfaces to support concurrency, such as ConcurrentHashMap and BlockingQueue. These structures ensure thread safety and efficient access in multi-threaded environments. Using concurrent collections helps prevent errors and improves the reliability of your programs. We've explored the essentials of Java collections, exception handling, and multi-threading. Understanding the differences between sets, maps, arrays, and lists, as well as how to handle exceptions and manage threads, is crucial for writing robust and efficient Java programs. These concepts form the foundation for advanced Java development and help you build scalable, maintainable applications. Mastering Java collections, exception handling, and multi-threading unlocks the power of the language. By leveraging the right data structures, handling errors gracefully, and managing concurrent tasks, you can create applications that are both efficient and reliable. Keep exploring these concepts to deepen your understanding and enhance your programming skills.